right. So welcome to Periodic Table at a Glance. So this is the worksheet you should have open in front of you, or shortly. And you're going to make a copy of this periodic table at a glance draw. So I'll just make one right now. And so there you have it. You can do this in a couple different ways. You can print out this document if you have access to a printer, and you can do all the coloring and labeling and stuff by hand. However, the activity is designed for you to do online, and that's what I'm going to show you. So that's what I suspect most people will be doing. All right, so we made a copy. You're choosing which one, and now we're on to number 3, which is a classification of elements. Well, one of the 3 major classifications on the periodic table are whether certain elements are metals, nonmetals, or metalloids. So what I'd like you to do is go to this link, and on there you'll find the properties of metals, nonmetals, and metalloids, so you can fill in this table. So you might want to take a few minutes and pause and do that, and then we'll keep going. All right, so number 4 is complete the key on the periodic table draw. So I'm going back over here, and here's my key right here at the top. So I need to choose some colors for metals, nonmetals, and metalloids. So I'm going to go up here, I'm going to pick a square, I'm going to put it in here in metals, and I am going to go to the paint bucket, and I'm going to say that that's green. Right? But now the problem with the green the way it is it's solid. So anything I write down here or in here is not going to show up. So I need to actually make that transparent. So I click Fill Color again, but then I go down to Custom. And so here's the color I have. And then down here you can see that it says Transparency. So I want to move this over to be about half transparent. It's not really critical, but and there it is. So now I have this pale green color that you can see through. And I want to do the same for nonmetals and metalloids. So if I click on this square, I can just Command D to duplicate it. I don't know if that works on Chromebooks, but that works here. And so my nonmetals, I think I'm going to make, those pink. But I still have to make that transparent, so I go to Custom, come about halfway down, okay, and now I have that. And then my metalloids, I think I'm going to make those yellow. Same thing with the transparency business. And so now I'm good to go. All right. So let's talk about metals first. So I'm just going to duplicate that square again, and I'm going to come down here. And I know that this first square right here is not a metal, but I also know that everybody in these 2 columns are metals. So I'm going to drag my little square over, and I'm going to pull that down. So those are all metals. I'm then going to duplicate that, line it up, pull it down, and I know that everybody, all of these elements right in here are also all metals. So I'm going to drag that over, and those are all metals. I'm telling you, for later, this square right here that's adjacent to that line, so not the first one, the second one down here, has to be its own square because we're going to write in that. Okay, so that's that, and the rest of this column is metal, and then this column over here, not that one, then this one is also a metal. Okay, so it doesn't matter at the moment what these elements are. What you're looking at here is a pattern. Okay, so when you're thinking about the periodic table, you can visualize all this green over here and know that those are metals. Now, another way to tell them apart from each other is by their group name, or to identify the fact that they're metals is by their group name. So this first column, they're called the alkali metals. Tells you right there that they're metals. This is the alkaline earth metals. Again, it tells you that they're metals. And this whole big section in here, those are called the transition metals. Okay, so metals, metals, metals. Now once you get over here, it gets a little different with the name, so we'll put that off for a minute. So now let's identify the non-metals. I'm going to grab some of my pink. In this case, this first, I can increase the size of this so it's easier for me to work with anyway. So for this first row, I want each one of these to be its own separate colored square because I want to write in them later. So I'm just going to keep duplicating that. Well, I don't need to do it for the last two, but so now what I can do here and drag it over, I can duplicate that, except that it doesn't include that one, and I can duplicate that, but it doesn't include that one. All right, and so now I can duplicate that because these last two are non-metals. Right, so all of this over here, oops, forgot about that one. It's also a non-metal. Oops. Now, you may be able to figure this out, and eventually you would, but let's, for the sake of this activity, I'm also going to take one of these purple squares, and I'm going to put them in, in this square right over here in the alkali metals. So when I view this, I can see all my metals are over here except for this. All my non-metals are over here. And so all of these that are still white are metalloids. So I'm going to go grab my metalloid color and I duplicate it. I'm going to put this in here. And then I'm going to duplicate that. Now, here, I can just click and drag, and that's going to be those two, and that's going to be those two. Yes. So now we have our periodic table divided into those three major categories of metals in the green, nonmetals in the purple, and metalloids in the yellow. And we'll come back and talk about some individual ones of these in a little while. So, continuing on with family or group names, this group is called the boron group. This is called the carbon group. This is called the nitrogen group. And this is called the oxygen group. And you'll say, Ms. Millender, do you expect me to memorize this? And I'll say you don't need to, because guess what element is right here? Boron, carbon, nitrogen, oxygen. So in fact, if you just look at the element in the top of each of these columns, it tells you what the group name is. So that's good. Now these over here, the second to last column is the halogens. Oops, too many A's. Halogens. And this last column are the noble gases, which you've probably heard of. All right, so these are all group, sometimes called family names. Okay, and you should know those. All right. So now let's go to this next one. This next arrow is actually, instead of group or family names, this is group or family numbers. On many periodic tables, you'll see these group and family numbers are indicated by Roman numerals, but on most of them, more modern ones, they're not. So we can just go through these, and it's just numerical 1, 2, 3, 4, 5, 6, 7, 8, 9, whoops, 10. All right, so this is going to be, nope. All right, so I need to make all of the rest of these 11 font. I'll go up here and change that to 11. All right, so this is, whoops, this is column 10, column 11, 12, 13, 14, 15, 16, 17, and 18. And so those will help you figure out some other stuff that we'll get to in a few minutes. So you know about energy levels, in that those electrons found close to the nucleus have the least amount of energy, and those that are found in higher energy levels have more energy. And we'll talk more about that. But each of those energy levels is actually called a period. So what goes in here is actually the period number, and it's the same numerical sort of pattern, okay? All right. So this is the period number, all right? And it tells you the number of energy levels in elements in that row. Okay, so just a quick reminder that, rows go across and columns go up and down, right? If you're sitting in a particular row at a concert or at the movie theater, right, they go across, and columns hold up buildings. So anyway, so rows and columns. So period number is the number of energy levels, just so that's one of the things you need to know. Then down here, for these last empty shapes, what we're going to be looking at here are what are called valence electrons. I'll move that up just a little bit. All right, so valence electrons, and I'm just going to shorten electrons by doing that, an E with a negative sign. Electron, no, come on. I hate when it does that. Electrons found in the outermost S and P orbitals. These electrons are involved in chemical reactions. So the number of valence electrons has something to do with how reactive things are with other things. All right, and so I'm just going to pull that up, and there we are. Now, just like we had before, this first circle, everybody in that column has one valence electron. Everybody in this column has two. We're going to skip all of these transition metals, and the reason for that is they have orbitals that are not S and P's. There are other orbitals called d orbitals, which we're not going to get into, so that's why we skip those. All right, and then keeping up with the pattern, that's 3, 4, 5, 6, 7, 8. All right. Now you say, well, what is that little circle for? Well, if you look at row 1, right, and we can see from the period number that every element in this row, which just happens to be 2 of them, we have here and here, only has 1 energy level. And as you hopefully remember, the first energy level only has 1 s orbital. It's too small for any p orbitals, so it just has the 1 s. And you also know that orbitals can only hold a maximum of 2 valence electrons. So in fact, this element right here, which happens to be helium, actually only has 2 valence electrons because it only has the 1 s orbital. So all of these have 8 except for helium, which has 2, because this only has 1 energy level, where this whole row has 2 and 3 and 4 and 5. Okay, so hopefully that makes sense to you. Okay, now I told you we'd come back and look at these column numbers, because you'll find these column numbers on all periodic tables. Right? What you don't find on any periodic tables is this pattern we set up on the bottom of valence electrons. Okay, we separated it because we wanted you to see that pattern as well. But if you compare these, this is column 1, 1 valence electron. This is column 2, 2 valence electrons. But now we skip all the transition metals and we're over here to 3 valence electrons. Well, if you look, the number in the ones place matches that 3. So yes, it's group 13 or column 13, but if you just look at the 3, it tells you how many valence electrons. And the same with 14 and 4 and 15 and 5 and so on and so on. Okay, so you can use the group number to figure out the number of valence electrons as long as you skip the transition metals. All right, so that's how those connect. And that is the periodic table at a glance. There are 2 small things that I want to go over before I finish up, and they have to do with, not problems, they have to do with something in the pattern of colors that doesn't match. Well, this one is obvious, right? This is all green, and now this one is pink. So something's going on here. Why is this pink one way over here? Can you see the other sort of break in a pattern? All right, well, maybe you figured it out. It's actually this green one, because if you look at this zigzag line here, you'll see that there are metalloids above and below the horizontal part. Above and below, above and below, above, and oops. Well, this is in fact aluminum. And you know that aluminum is a metal. It's not a great conductor of heat and electricity, but it does conduct. It's you can make wires and aluminum sheets, and you can, and it will conduct electricity. So that's why that's out of this, because aluminum is clearly a metal, and it's not a metalloid like all those yellow ones. And most of you know what element is over here. What is it? Hydrogen, right. Now, why is hydrogen way over here? Well, the reason it is not because it's a metal, but because hydrogen also only has 1 valence electron. So in order to keep that pattern going with valence electrons, that's where it ended up. Okay, you could probably rationalize moving it over here into the halogens, but it doesn't react the same as the halogens. So, well, it can. But anyway, so the hydrogen over here is the exception because it's a non-metal in a region which is all metals. And aluminum is an exception in that you would predict that this would be a metalloid, but in fact it's not. Okay, so those are the 2 exceptions to the rules. This looks pretty good. make sure you've named this something where you can find it. So you go back over to your periodic table at a glance worksheet. Hopefully you've filled out the properties. All right, now you're just going to, insert, but this time you're going to insert a drawing. And you're going to say from the drive. This is the drawing that you were just working on. So you would say, I guess mine is called copy of periodic table at a glance. So that's the one I want. You could probably keep it linked to the source just to make it easier to go back to it, but it doesn't really matter. And then you're going to insert it there, and there it is. Okay, so then you're going to save that as a PDF, right? Download as a PDF, okay? And then submit that to Schoology. And that, my dear, is periodic table at a glance. If you have any questions, just contact your teacher. Thanks.